Okay, what if the secret to a cleaner, more efficient future was as simple as just flipping a recipe inside out? It sounds kind of crazy, right? But today, we're going to dig into a breakthrough in manufacturing that could honestly change everything. I'm talking about the fuel in your car, the medicines you might take, you name it. So yeah, let's get right into it.
Think about this for a second. The clean air coming out of your car's exhaust, the fuel that powers pretty much our entire world, even life-saving medicines we all rely on, they all share this one hidden ingredient. It's like this unsung hero that makes all of modern industry even possible. So, any guesses what it is? Yep, you guessed it, catalysts. These things are the absolute workhorses of the chemical industry. And believe it or not, a really recent breakthrough is completely flipping the script on how we make them.
All right, Section 1, Industry's Unsung Heroes. So, what exactly is a catalyst anyway? And why should you even care? Let's break it all down.
So, a catalyst, a good way to think about it is like a chemical matchmaker. Seriously, its whole job is to bring different molecules together and help them react like way faster than they ever would on their own. And then, and this is the cool part, it just steps away, completely unchanged, ready to go again. It's amazing. Without these things, so many of the industrial processes we depend on would be just too slow, or they'd use way too much energy to even be practical.
Okay, so if we take a closer look, the most common type you see in industry are called heterogeneous catalysts, and they've really got two main parts. First, you've got what's called the active phase. These are these super tiny nanoparticles that do all the real work, the actual matchmaking. And when I say tiny, I really mean it. We're talking about particles engineered at the molecular level. Their exact size is everything. It's what makes them so powerful. Then you have the support. This is basically a porous structure, kind of like a sponge, that holds all these little nanoparticles in place. The perfect example you probably heard of? The catalytic converter in your car. It uses this exact setup to turn all that nasty, toxic exhaust into much safer gases.
Section 2. The Catalyst Conundrum. So here's the thing. For decades, the way we've been making these super important components, well, it's had a pretty major flaw, a big one actually, and it's been seriously holding back how well they can perform.
Okay, so here's the heart of the problem. That support structure, the part that's just there to hold everything together, get this, it makes up the vast majority of the catalyst's weight. We're talking anywhere from 60 to a mind-boggling 99%. Meanwhile, those active nanoparticles, the part that does literally all the work, it's just this tiny fraction of the whole thing. Kind of seems backward, right?
So you're probably thinking, well, the obvious solution is just to add more of the active ingredient, right? More nanoparticles equals a more powerful catalyst. And logically, yeah, that makes perfect sense. But with the traditional method, it totally backfires. The moment you try to load up that support structure with more nanoparticles, they start clumping together. They lose that perfect size and shape that makes them work so well, and their effectiveness just nosedives.
All right, Section 3, a recipe flipped inside out. So yeah, this old recipe was clearly a dead end. It was holding everything back. So a team of researchers at Khalifa University decided it was time to just rethink the entire process, and they started with one really simple but really powerful question.
What if, instead of trying to stick the active ingredient onto the support, what if we built a support around the active ingredient? I mean, just flip it completely. This super simple reversal is the core idea behind a brand new method called NAEMs. And yeah, it pretty much changes everything.
So, on to Section 4, how NEMS works. How does this new inside-out method actually work in practice? Well, the process, NEMS, is this really elegant four-step approach that gives scientists and engineers a level of control they've just never had before.
And the process itself is actually pretty intuitive when you hear it. First, you start with the most important part, the active ingredient. These perfectly sized nanoparticles that act like little seeds. Step 2, you literally grow the porous support structure around them like building a house around the furniture. Step 3, some special molecules come in and form this temporary crown around each nanoparticle, kind of to protect it. And then finally, Step 4, that crown is washed away, and what's left behind is this perfect, tiny little reaction chamber, exactly where you need it. I mean, this level of precision and control, it's a total game changer.
Okay, Section 5, putting NEMS to the test. Look, an elegant theory is one thing, right? But the real question is, does it actually work out in the real world? So the researchers put their new catalyst through its paces in a really demanding industrial process. And they didn't pick an easy one. They chose a supercritical process, the selective oxidation of hydrogen sulfide. Commercially, this is known as the superclause process, and it's all about taking a seriously toxic gas and safely turning it into valuable, pure sulfur. Trust me, this is a tough test for any catalyst.
And the results? Honestly, they were staggering. First off, the NEMS catalyst showed over 95% selectivity. Now, what that means is that it was incredibly precise. It was making almost only the valuable sulfur they wanted with barely any wasteful byproducts. And then, on top of that, it achieved near-complete conversion. We're talking it transformed almost 100% of that toxic hydrogen sulfide. That level of efficiency is it's incredible. It's almost unheard of.
But here's the real kicker. The NEMS catalyst pulled off these amazing results while using just a tiny fraction of the material that the old conventional methods require. So let's recap. It's more powerful, it's more precise, and it's way, way more efficient.
Which brings us to our final section, number 6, the bigger picture. So, what does this all mean? Why does flipping a simple recipe inside out matter so much for the future of, well, everything?
Look, the NEMS approach really is a game changer because it solves all the fundamental problems of the old way of doing things. It gives scientists total, independent control over those crucial nanoparticles. It lets them pack and weigh more of the active ingredient without having to worry about it clumping up and becoming useless, and the process itself is simple enough that it could be adopted pretty widely. It is the absolute definition of doing more with less.
This breakthrough really gives us the tools to custom design what you could call super effective catalysts for just countless applications. I mean, think about it. Creating cleaner energy, developing new medicines, making more sustainable materials. Building catalysts from the inside out just opens up this whole new world of possibilities. So the only real question left is, what industry is it going to transform next?